Okay, in this video we're going to go over quadratic functions, but how to translate a word problem into an equation so we can actually solve the problem. Remember that math is just a language, and basically you can translate from words to equations and equations back to words. So that's what we're going to try with this particular problem, and it's going to reflect quadratic functions. I'm going to show you how to do that. So here's our problem. It says an auditorium has seats for 1,200 people. So for the past several days, the auditorium has been filled to capacity for each show. Now, currently, the tickets are costing $5 each, and the owner wants to increase the ticket prices. He figures he's got the demand, he might as well just increase the prices. But he does estimate that for every 50 cents increase in the price of one ticket, probably 100 fewer people will attend, because people don't like to necessarily pay a higher price, right? So what ticket price will maximize his profit? Now remember that in a parabola or quadratic function, you can get maximums or minimums depending on which way the parabola opens, right? So let's see if we can translate this and figure it out. Now the first thing that we're going to do is that the revenue is going to be equal to the number of tickets sold versus, or times rather, the price of the ticket, right? So if I had, like, for example, one ticket and I sold it for $5, my revenue would be 1 times 5, or $5, etc., etc. Okay. Now, so I have that equation here, but let's see what else we've got going here. Now this says that this auditorium has seats for 1,200 people. Okay, so let's see what we can do with that. We know we have 1,200 people. Let me get my equation editor out here for just 1 second. So if I have 1,200 people, and I'm going to estimate that, and that's going to be the number of tickets being sold, right? And that for every ticket that is increased in price, 100 people will diminish. So, for example, my x. Let me start all over again. I should put one more thing in here. I should say that x is equal to the number of 50-cent increases. All right. So when I look at this equation here, just ignore that for just 1 second here. If I look at this, expression right here, 1,200 minus 100x, right? So if I have a 150% increase, I know that again 150% increase, that 100 fewer people will actually come. So it's 1,200 minus 100 times whatever the increase is. If I put in 2 increases, then according to my thing, 200 less people, then now I've only sold 1,000 tickets. Okay, so let's put that in parentheses. Let me put it there as well. Okay, so that's one of my things I can translate. That would be the number of tickets being sold, right? So now what am I going to do about translating the price of my ticket? Well, let's see. I know that I have $5, right? And that if I increase it 50%, so it should be $5 or 5 plus 0.5 or 0.50x, right? So because it's $5 and plus whatever increase I'm going to put in there. So let me just go ahead and insert that also as a, there we go. I know it's $5, it's just 5 rather, plus 0.50x. And again, I probably want to put that in parentheses. And there it is. Now look what you've got here. Basically you have the number of tickets sold times the price of the ticket, which is right here, and that's going to be equal to my revenue. All right? Oops, let me try that again. Equals. Now, you might recognize this as a quadratic equation, right? Because remember, when we factor a quadratic equation, you're going to get a binomial times a binomial. Let's go ahead and do this one. Let's go ahead and multiply it out and see what we actually come up with. So we know, let's just do a quick FOIL here, that net revenue is going to be equal to 6,000. So 1,200 times 5 is 6,000. Let me just put this in a equation editor. It's always a little bit easier, I think. It looks better. So it's going to be 6,000 plus, looks like when I do the 2, it'll be 100x, right? Oops, sorry. Let's try that one more time. That's going to be plus 100x. And that's going to be minus, right? Because the negative times a positive is going to be, looks like it's going to be 50x squared, doesn't it? Yeah. If we multiply that out, so let's just put that in there. 50x squared. Okay, now I think we have our quadratic function, right? So we can go ahead and figure out a couple of things from here. Now let's rearrange this, right? Let's rearrange this and put it in the standard form where the quadratic term goes first, the linear term is second, and then the constant is third. So I'm going to say revenue is equal to, it looks like it's a negative 50x squared. Okay, so let's go ahead and put that down there. I can just copy this. Let me try something real quick. Yep, there we go. So I'm going to just edit what's inside here. So negative 50x squared, and that's going to be plus 100x, right? Because it's a positive, and then a plus 6,000. Okay, so now we have our new equation. I could actually put that equation in Desmos. Or I can actually also, remember, just do the A, the B, and the C. And my vertex, and I know this is going to be pointing down, so my parabola is going to be an upside down parabola. And I know that my vertex, which, again, the highest point, it represents the maximum, right, of a quadratic. So I can just do A is equal to negative 50, B is equal to 100, C is equal to 6,000, and I would be able to tell with the vertex formula what the maximum profit would be, right? Because the X would be, again, just the number of the price, number of 50% increases, but the Y would equal the revenue. And so wherever it's maximum, which would be at the vertex, right? So let's see that. We can put that actually in Desmos. Let me just go ahead and get Desmos real quickly. Where are you, Desmos? There it is. Let me just go ahead and shift this so you can see everything. Looks like, put this over here. I want that there. And I think I want the recorder there so you can actually see what I'm putting inside, okay? So, we said it was equal to negative 50x squared plus 100x, and then we said minus, or plus rather, 6,000. There's 600, there's 6,000. Let me go over and adjust the numbers real quickly. So my x's can really just go up to like about a 20, that's fine. But my y's, right, probably should go up to, I don't know, let's say 10,000. And now we can actually see the quadratic that's formed. Let's go ahead and take a quick look at this parabola, okay, because it does look like a parabola. Now notice that the 6,000 represents the y-intercept, and sure enough, there it is, where x is 0, where there are no increases, where the input is, there are no increases. I sold $6,000 worth of tickets, right? Now, according to this, my high point is right here. So when I have sold one 50% increase in price, I will sell $6,050 worth of revenue. But then after that, if I do like 2, like right there, right, which is approximately 2, my revenue goes actually down. So instead, if I sold a $6 ticket, right, 2 increases, 2 50% increases, my revenue is going to go down to $6,001. All right, so it looks like the maximum profit is going to take place at the vertex, which is, again, just 150% increase. Okay, I hope that was available. I hope that made sense to you. So remember, when you are creating, let me switch back to here. When you're creating this, let me go ahead and switch it back over here again. Here we go. When you're translating into a quadratic function, you're going to need 2 binomials, right? The first thing you should always do, again, is to write out what the common sense equation is. Number of tickets, for example, sold times the price of the ticket will give me my revenue. Make x equal to whatever, again, makes sense in the problem, and then go ahead and try to create 2 binomials, and then create, because you have 2 binomials, you're going to be able to create a quadratic equation and then shift it into standard form, and then you can do whatever you want at this point. You can put it into Desmos, use the vertex formula, find the maximum or the minimum, and just answer the question. Okay, I hope that was helpful to you. That was quite a long-winded problem.